All right, in section 7.3, we look at actually proving that triangles are similar. So there's three different theorems that we could use here. We have the side-side-side similarity theorem. We have an angle-angle similarity theorem, and we have a side-angle-side similarity theorem. The key to the side-angle-side is we have to make sure that the angle is the included angle between the sides. So it's similar to first semester, but you got to make sure that that angle is like in between the two sides that are similar on the triangle. So when we talk about like actually verifying that these triangles are similar, it's really that we're piecing together a puzzle. Okay, they want to know, are triangle ABC and triangle DEF similar? For example, 3A. And with this, you look at what's given to you. Okay. In this picture, the only thing that they give me on these triangles are the sides. All right. So in order to like determine if these are similar or not, we have to determine using side, side, side. Okay, that is the only way we'd be able to like show whether or not these triangles are similar, because that's the only information they gave us. The way you're going to determine if these are similar or not, going by side, 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 is setting up proportions. So I want to match up my sides. AB, okay, so this side going up and down, goes with DE. And we're going to go ahead and make a fraction. AB divided by DE. So we got 3 divided by 4/5, or sorry, 4.5. Next one, we got BC. And then BC is going to go ahead and go with EF, the bottom over here. So BC, EF. BC is 4. EF is 6. And then the last one we got to worry about are my diagonal. In this case, it looks like it's a hypotenuse. And yeah, they are hypotenuse because they're right triangles. So you got AC going with DF. So 5 over 7.5. All right, with this, the key is you have to make sure that when you make these proportions that you have the same triangle in the numerator for all three of your proportions. So if you notice, I got ABC is in the numerator for all three, DEF is in the denominator for all three, and then you have to make sure you match the sides up. From there, if we go ahead and simplify these fractions out, so using a calculator, they are all going to work down to 2/3. And since they all equal the same thing, that would be my scale factor in this case. All right, to get from one to the other, we would multiply by 2/3. We can go ahead and say that they are similar. So we're going to draw a similarity statement. It would be triangle ABC is similar. So we have this little wavy line, meaning that they are similar to triangle DEF, and they're similar by side, 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 because all three of the sides are proportional. All right, so that's 3A. 3B is the one where you got to do a little more work. So you look at 3B, they give us a picture right here. They want PQS and RQP. They want us to compare those two triangles and see if they're similar. Like first semester, first thing you want to do here is redraw them. So if I go ahead and draw PQS, that's the one on the outside, we're going to go S to P to Q. Go ahead and label the sides we have. So PQ is 18. SQ is the whole base right here. So we have to do 15 and 12 to give us 27. The other triangle they're worried about is RQP. So it's that little one on the right. If I go ahead and go from R to Q to P, so I got R to Q to P. Okay, so if I go RQP, we got 18 and we got 12. Okay, with this, you have to look at the information they give you. Okay, the information that they give me is that we just have two sides in each triangle. If we just have two sides in each triangle, we cannot use side, side, side. Okay, so that's out the door. Can't use side, side, side. I look at it, there's really no mention of an angle explicitly, but they both share angle Q. So if they both share angle Q, we can go ahead and say that those are congruent because they literally share them. Okay, so since they share angle Q, go ahead and put a congruent symbol in there. But that's the only angle they mention. So we can't use angle. So we go to our last and third one. Okay, we have side, angle, side. If I work my way around, we go side, angle, side, side, angle, side. So we could possibly try this out or figure this out using side, angle, side. What we would have to do now is see if the two sides are proportional or not. So looking at what they're asking us to prove. They want PQS to RQP. So I have PQ. We have to go ahead and match it up to the other triangle. So the other triangle goes RQ. So our first thing here would be PQ to RQ. So PQ is 18. RQ is 12. We go ahead and simplify that. We get 3/2. Okay. In order now for these two triangles to be similar, we need to, when we find proportion for SQ and RQ, sorry, SQ and PQ, they have to equal 3/2. So again, I go ahead and use my top triangle, and my red one is going to go up top. So we're going to have SQ, and then we're going to throw that over the PQ from the blue. Okay, so throwing in SQ is 27. PQ is 18. 27 divided by 18 simplifies to 3/2. So since these two are the same, we say they are proportional. We have proportional sides. We have an included angle. We can say the triangles are similar. So you have triangle PQS similar to triangle RQP by side, angle, side. Okay, we got one more to work with. That's going to be example 4. So example 4, they're asking us what is MN. Okay, so they want to know what is the length of MN in this triangle. So first off, we have to figure out like if they're similar or not. So they flat out tell us they're similar, but realize we should be able to prove this. All right. Proving this, we go ahead and we have congruent angles here and here, because they are vertical angles. So from first semester, we know, all right, vertical angles. And then these are isosceles triangles. So since they are isosceles triangles, the base angles for a given triangle are congruent. And if the base angles are congruent, and then our third one is the same for each, it means that they need to be congruent in each of them. Okay, so the triangles are similar by the angle theorem. So from here, we have to match up our picture. Okay, so we're going to have these be congruent. So we're going to say JLK. Now this one's actually not the end of the world, but I'm going to go from J to L to K. Okay, so JLK is going to be similar to, we're going to go triangle MLN. Honestly, on this one, it doesn't matter which way you work it around. You just have to make sure that your middle letter is L. Okay, outside of that, like the other angles are congruent. And we did this by angle. All right, so now we know they're similar. We need to figure out, okay, what the heck are these measurements for MN? Okay, so doing that, we're going to separate proportion. I want to find MN, so I'm going to go ahead and write MN down. And I look at the other triangle and see what that matches up with. Well, MN is going to go with JK. So you have MN over JK equals. And then in these triangles, I know that my other sides are 75. So since I had MN up top on the left, On the right, I also have to have the 1 up top for my proportion. So we're going to have 1 over 75 from the other side. Okay. From here, we're just plugging in. So we know JK is 10. So we have MN over 10 equals 1 over 75. And then you need to go ahead and solve for MN. So we did this in class the other day. You multiply the 10 up. You're going to have MN equals 10 over 75, which is going to simplify to, what is that going to be? 2/15.